Hey guys, it's me, it's Mrs. Applegarth. These are going to be the notes for geometry, section 2 from chapter 2, and we're going to be talking conditional statements. The first thing, other than the title, that I want you to write down in your notes is that a conditional statement has a hypothesis that starts with if, and a conclusion that starts with then. So usually we shorthand stuff because we love to do shorthand. Usually we shorthand our hypothesis with the letter P. So whatever your hypothesis is, it could be that you're going to study. So if I'm going to study, I'm going to call that hypothesis P. And we represent, using shorthand, the conclusion by using a Q. So then we say, if P, so whatever your hypothesis is, then Q. So let's, and in shorthand, we even write it shorter. If P, so we read this, if P, then Q, or P implies Q. It's crazy, right? So let's look at it in real words. If I study, then I will get 100% on the test. So the conditional statement for this would be, if I study, then I'll get 100% on the test. Studying is P, 100% on the test is Q. If P, then Q, or P arrow Q. So a conditional statement is just a special way to write a statement. Now that you guys have this concept clearly down, let's go ahead and mix it up for you. A different way, some things you can do to a conditional statement is you can make a negation. So you can say the opposite of the statement. So the opposite of studying is not studying. A negation is like in math when we make a number negative. So when we make a number negative, we use a negative sign, but this negation, we are going to use a tilde because we're not using real numbers here, we're using a tilde. So if I want to shorthand my hypothesis, so I'm going to say I'm not going to study, I do a little tilde and a P. That says not studying, or the opposite of your hypothesis. We can also say not Q. So we can say then that means not 100% on the test. All right, now we can mix up our conditional statement by flipping the hypothesis and conclusion. So if I flipped it, the Q would go first. I have it here. If Q, then P. And let's do that. If I get 100% on the test, then I studied. So converse flips the two items. The inverse keeps our hypothesis and conclusion in the same order. It just negates it. So it's like saying, if I do not study, then I will not get 100% on the test. So it's not P, then not Q. And the contrapositive, he flips it and negates it. So he says we're going to switch the P and the Q, and we're going to make them opposite. So we're going to say, if I do not get 100% on the test, then I did not study. And I do want you guys to write each one of these items down. Negation is the opposite. Converse flips the hypothesis and the conclusion. Inverse keeps the same order, just makes them opposite. Contrapositive flips and makes the hypothesis and conclusion the opposites. Okay, and we're going to do a lot of examples, so write these down. You'll get, we're starting to create neurons in your brain. It'll come together as we look at the examples. So let me tell you about equivalent statements. So to be an equivalent statement, two statements have to be, both of them either both of them have to be true or both of them have to be false. So the original conditional statement and the contrapositive statement will always have the same truth value. And the inverse and the converse statements will always have the same truth value. And I was like, that, you know, this is a lot of words. Let me throw up an example so that my students can see what we're talking about. So write this down and I'm going to explain what I mean. So if we look at a conditional statement, if the measure of angle A is 15, then angle A is acute. That's a true statement. If we do the converse where we switch it, if angle A is acute, then the measure of angle A is 15. The reason that this now becomes false is because what if our angle is 30 degrees? The inverse of this conditional statement is if the measure of angle A is not equal to 15, then angle A is not acute. And we can find a counterexample for that. What if it's equal to 20? Then it would be acute. So that's why this is a false statement. Then we look at the contrapositive where we have it flipped and the knots. If angle A is not acute, then the measure of angle A is not equal to 15. Well, that's true because if you're not acute, you can't be, you're like 105, then you're not equal to 15. So that this contrapositive is definitely true. So the conditional and the contrapositive always have the same truth value. And the converse and the inverse always have the same truth value as each other. So they like go together. That's what this means. You don't have to write this down. I'm just giving it to you as something you can reference. Okay, let's look at example 1. Write the conditional statement in if-then form. So what I did is I put if and then a big space and then a big space because I want you guys to see that if we're writing a conditional statement, the if comes first, the then's in the middle, and we're moving these guys around. So 2 points are collinear if they lie on the same line. So we're going to start with this part. 2 points are collinear. And we're going to put it right between if and then. If 2 points are collinear, then we're going to say take the second part, the conclusion. They lie on the same line. I do want you guys to write that down. If 2 points are collinear, then they lie on the same line. Let's look at example 1b. A number divisible by 9 is also divisible by 3. So a number divisible by 9 is our hypothesis. If a number divisible by 9, well, that kind of sounds weird. So we need, when we get a hypothesis or a conclusion that doesn't have the kind of the right words, the participles aren't there, the articles aren't there, or the verb isn't there, we have to add that in. So I would say this as if a number is divisible by 9. So I'm going to trade this out. So sometimes we have to use our English language arts skills and make the sentence make sense. So if a number is divisible by 9, then it is also divisible by 3. Then is also, oh, well, it's kind of missing that English, so I'm going to add the it along with it. So it makes sense. So now we can say if a number is divisible by 9, then it is also divisible by 3. So when you create your conditional statement, feel free to add in the proper kind of intersection words so that it makes sense. All right. All right, let's look at example 2 together. In this scenario, we're going to write a counterexample to the following conditional statement. If x squared is equal to 16, then x is equal to 4. I want you guys to think about a counterexample. So when is there a possible number out there that when I square it could potentially equal 16 that is not 4? So anytime we're looking at numbers and we want to think of counterexamples, we talked about this last week, we want to think about zeros and negatives and fractions. So in this case, because it's a square, I'm going to ask you to think about two negatives making a positive, because the squared means I'm going to multiply the two numbers together. So if they were a negative number, it would make a positive 16. So our counterexample is going to be x equals negative 4, because negative 4 squared is 16. All right, let's look at example B, to example 2b. If an angle is acute, I actually do want you to write that down. So write this down and write the counterexample. If an angle is acute, then it is 30 degrees. So we need to think of a counterexample to an angle that's acute that is not 30 degrees. Oh, well, we think about it that way, that's totally easy. A counterexample would be, I don't know, 15 degrees or 45 degrees or 89 degrees. So any angle that's acute, as long as it's not 30, is a counterexample. Yay, easy, right? So feel free, if you guys want to change this counterexample number to any number between 89 and 1 degrees, that's as long as it's not 30, it will be correct. All right, we're going to give a counterexample to the converse of this statement. If a person lives in Sacramento, then he or she lives in California. So the first thing we have to do is create the converse of this statement. Before we can give a counterexample, we need to know what the converse is. So if a person lives in California, then he or she lives in Sacramento. So the converse, remember, is when we switch the hypothesis and the conclusion. So if a person lives in California, then he or she lives in Sacramento. I know a great counterexample to that. You live in California, and you also live in whatever city you live in, whether that's Placerville, Pollock Pines, Diamond Springs, Pleasant Valley, Camino. I don't yet know any of my students that live in Sacramento. So if you live in California and you also live in our district area, then you are a counterexample. Very exciting. So go ahead and make sure, please fill in your name. And you guys, that's going to be our phrase of to get credit. If you missed the assignment, you're going to send me counterexample you ? That's our secret phrase to get credit in case you missed this live lesson. All right, we are going to, in example 4, write the inverse, converse, and contrapositive of this statement. I like this little table because it gives us the original, the inverse, the converse, the contrapositive, a little space for each one. And now what I did is I made each of these little pieces. So just to remember, each of inverse, converse, and contrapositive is going to have an if. The hypothesis is the measure of angle A is equal to 30 degrees. All of these items are going to have a then. And then the conclusion is that angle A is acute. So I just made different little copies of each one of these items so that I could just pull and drag so you can see how easy, once you have the original, how easy it is to put together inverse, converse, contrapositive. If you can't remember what each one is, we can just dial back. Move this. So the inverse is when you negate the hypothesis and conclusion. The converse is when you flip the hypothesis and conclusion. And the contrapositive is when you do both. You flip and you negate. So we can come back here and just, this is why we have notes so you guys can, you're not asked to memorize it right off the bat. We use it, we grow those neurons, and then we remember it eventually. So the inverse of this, well, let's start with our if. So inverse says we negate the hypothesis and conclusion. So we keep the same hypothesis and conclusion, we just put our knots in there. So if the measure of angle A is not equal to 30 degrees, then angle A is not acute. All right, let's look at the converse so that we remember. A converse it flips the hypothesis and conclusion, so it keeps everything the same, just flips them around. So let's get our if. And it takes our conclusion and puts it first. If angle A is acute, then the measure of angle A is equal to 30 degrees. Not that that's true, because we looked at this before and we saw, oh yeah, that really doesn't ring true. But whether it's true or false, that is the converse of the statement. All right, so the last one is the contrapositive. We have our if. Contrapositive flips it and negates it. So let's flip it. If angle A, and let's put our not in there, is not acute, then measure of angle A is not going to equal 30 degrees. All right, you guys, I do want you to write down each one of these items so that you have a really good example of inverse, converse, and contrapositive. Okay. So the next item we're going to look at is point, line, and plain postulates. Please remember that a postulate is a statement that we take as true. So I'm going to look at these as number 5, number 6, number 7, number 8, number 9, number 10, and number 11. We're going to write them down because we're going to use them, and it's good for us to have this. If they're giving it to us as a postulate, we better keep it in our tool bank of notes. So postulate number 5 is through any 2 points, there exists exactly one line. Postulate number 6 is a line contains at least 2 points. Postulate number 7, if two lines intersect, then their intersection is exactly 1 point. 7 is kind of a big deal. Number 8, through any 3 collinear points, there exists exactly 1 plane. 3 non-collinear points, there exists exactly 1 plane. A plane contains at least 3 non-collinear points. And we've talked about some of these before, so if these are sounding familiar, it's because they are. If 2 points lie in a plane, then the line containing them lies in the plane. And our last one that we're going to look at today is if 2 planes intersect, then their intersection is a line. All right, we're going to use these postulates up here to tell, to verify the statement, and we're going to use the diagram to kind of help us see what we're talking about here. So there is exactly 1 line that passes through points A, so point A is right here, and B. There's 1 line that passes through points A and B. So let's look up here and see if we can find a statement that has 1 line and 2 points. Oh, it's the very first one. Through any 2 points, there exists exactly 1 line. So we're going to put number 5. Okay, for B, lines M and N intersect at point A. Let's see what that looks like. Lines M and N intersect at point A. So they intersect right here. So we need a statement that talks about 2 lines intersecting and 1 point. So a line contains at least 2 points. No, because we need not 2 points and 1 line, we need 2 lines and 1 point. If 2 lines intersect, then their intersection is exactly 1 point. Oh, that's what we need. 2 lines, 1 point. Yay, we found it. Okay, so let's go ahead and write that down. That would be number 7. There it is. I lost it in the weeds there. Okay. And the last piece, for example, 5 points A and B lie in plane P. So line N, which contains points A and B, also lies in plane P. So points A and B are in this plane P that comes out, shoots off to the kind of the right-hand side. So line N, which goes here, has points A and B on it, has to also be on plane P. So let's do an inventory here. We have 2 points, a plane, and a line. So we need the postulate that has 2 points, a plane, and a line. Well, here's 2 points lie in a plane. So that's 2 points in a plane. That's 3 of the 4 items that we need. Then the line containing them lies in the plane. Oh, it's here. It's the number 10. Goodness. Awesome. All right. Example 6, we're going to decide if our statement is true. If it's false, we're going to give a counterexample. Okay, so through any 3 points, there is a line. Well, we know our postulate says through any 2 points, there exists exactly 1 line. So let's go ahead and draw any 3 points. So I'm going to draw point A, point B, and point C. I cannot draw 1 line through these 3 points. So we're going to call this statement false. Sometimes you need a picture. I am definitely a visual learner. Sometimes you need a picture to help determine exactly what it's talking about. So there's no one straight line. I can't take any straight line and get it through in the 3 points. So just drawing 3 points kind of in this triangular shape is gonna be a counterexample. Okay, let's look at B. If 2 planes intersect, then their intersection is a line. Well, okay, let's do a little inventory. We have 2 planes and 1 line. So that's number 11 here. If 2 planes intersect, then their intersection is a line. And we can see that. This plane Q, which is shooting off kind of to the left, and this plane P, which shoots off kind of forward and to the right, they come together at line M. So this one, B, is true. And it's exactly that postulate from number 11. All right, last but not least, if line segment AB is equal, the measure of line segment AB is equal to the measure of line segment BC, then B is the midpoint of AC. And I'm going to tell y'all that this is false. Because if I have line AB and I break my stick in half, so it's got a crook in the middle, BC, even if AB and BC have the same length, B is not the midpoint of AC because AC is technically from here to here. And so the midpoint would be a different point than B. All right, and that's it. We made it to the end. Good job, guys. Sorry, I switched to a different page. So it took away my lovely picture. So I'll bring it back so you guys can write this down. All right, that's our notes for this Tuesday. Go ahead and if this is a makeup, go ahead and send me the secret phrase, and we will see you guys on Thursday.